Hello viewers, you are welcome to my YouTube channel. Today's video is about the installation of solar system components. This installation is about the UPS system or version. It is not the PV. The PV is the photovoltaic, which has to do with the solar panel. And then in that system there must be an external charge controller that takes the DC current from the panel and to the battery. But in this system, it is the UPS. UPS has an inbuilt charger that charges the battery. This system only needs the inverter or the UPS itself and the battery, and that is all. No solar panel and then no external charge controller. So the UPS works as an inverter. It works as an inverter and also works as a charger. An inverter converts the DC current from the battery into AC current, which is being required or needed by the appliances at home or the household appliances. So the appliances at home are designed to work with the AC current, not the DC current from the battery. That is why you need an inverter to convert it. An AC current has a frequency of 50 to 60 hertz, and the voltage, that is the DAC of 220 to 250. That is the standard used in Nigeria, which is the EU standard. The EU standard. Yeah. So in this case, the AC current, because of the frequency, it shocks. It moves up and down, haphazard, and that is why it shocks. That frequency of 50 to 60 hertz means it vibrates. You get it? It moves up and down 50 times in 1 second, and that is why it shocks. But the current from the battery, which is a DC current, doesn't shock because it moves in a straight line. So this video isn't gonna teach you about the sizing and the maintenance of the components one by one, because there's a video in that aspect. Because before you can buy the component, you must size. The sizing for specification, the sizing for costing, and the sizing for selection of the component. You don't just go to the market and pick a component off the shelf without knowing the specification. So it is by sizing or through sizing that you know the specification, and because of the specification, you know the cost of the component. So I'm going to talk about the installation. That's the connection or the wiring from the inverter or the UPS to the battery, which is the purpose of this video, and also how to operate the components. Yeah. So first and foremost, let's go to the various components. I have pictures on the components, various components. I will show you how they are, you get it, and how to connect it. And eventually there is a diagram, a system architecture of the whole thing, of the arrangement. That is diagrammatic representation of the system. You will see how the connections have been made from this point to that point. That is from the inverter to the battery, and then from the AC source or the input of the AC that charges the battery through the UPS or the inverter, and then the output source of the AC, that is from the inverter, moving out to power the appliances, moving out of the inverter into the building to power the appliances. Thank you very much. So let's go to the components. Yeah, first and foremost, I would recommend this cabinet. Open cabinet like this is recommended for the arrangement of the components if you want to keep them. An open cabinet is important because of ventilation. The components need to be ventilated. Let me show you why. Yeah, the inverter. This is the cooling system. It's a cooling fan of the inverter. It is very important. The inverter needs to be cooled because of the load having subjected to the inverter. It needs to be cool. It needs a ventilation. So an open cabinet is very important. Likewise, the battery. The battery has ventilation holes. These holes, these vents are for ventilation. 6, 1, 2, 3, 4, 5, 6 are for ventilation. The battery needs to be ventilated. That is why an open cabinet is important. If not, the battery may burst out. And when it does that, it's going to be catastrophic. The severity of the accident will be hazardous and catastrophic because there will be fatality if anybody is around the place or in the building. Thank you very much. Let's proceed to the component. Okay, this is the inverter. From the box of the inverter, you can see the inverter is 1000 VA. That is the capacity of the inverter. The power requirement of the inverter, 1000 watt or 1 kVA. Yeah, it is just a multiplier. You get it? It can be in kVA, that's kilowatt, in megawatt, in gigawatt. They are multipliers, but in this case is 1000 watt. That is 1000 VA or 1 kVA. And then this is the weight of the inverter is 10 kg. The dimension of the inverter in millimeter, you can see it there, and the year of manufacturing of the inverter. This is how the inverter is, how it looks like. This is the inverter. This is the front of the inverter. It is free power. The button here is the control button. You on and off. When you press on, well, when you press in, it's for the on. Then there's a screen that displays the performance of the whole system. It shows the voltage of the battery and it shows the load percentage of the inverter. Let's go to the battery. This battery from the box is a 220 ampere hour. That's the capacity. And this battery is a weight type. It's tubular. It is weight. Why is it weight? Because it needs to be refilled. The distilled water inside the battery, inside the cell of the battery, needs to be refilled whenever it goes down, depending on the usage of the battery. That may happen once in 6 months, or once in 1 year. It depends. So this tubular is a weight. It requires a bit of maintenance. That is the refilling of the distilled water and the cleaning of the surface of the battery where the holes for the ventilation are. Let me show you. These are the holes for the ventilation. So sometimes we clean it, and then for the refilling of the distilled water, that's the maintenance of this battery. This is the indicator. It's a floater indicator because it floats on top of the distilled water inside the cell of the battery. This is a 6-cell battery. 1, 2, 3, 4, 5, 6. 6 cells. So this indicator is floating on top of the distilled water inside the battery. Whenever the distilled water is draining or going down, this indicator, the red part, the red cap or the red part of the indicator will be going down, indicating the level of the distilled water. In this case, the distilled water is filled up. It is full in the cell. That is why the red cap or the red part of the indicator is at the top, is at this green line. But when it goes down to this red line at the bottom of the indicator, meaning the distilled water is finished and it must have to be refilled. Thank you very much. That's all about the battery. This is not the detail about the battery. There's a video on sizing and the maintenance of the battery. Then the inverter. Okay. The inverter, as you can see, this is the AC output of the inverter. That is the one that supplies to your building. The AC output of the inverter. This is the fuse of the inverter. This is a cooling fan. Then this button, the first button on top of the inverter by my left, that shows 150 to 200 ampere hour, and then 100 to 135 ampere hour shows the size of the battery you get of the battery. Whenever you turn in to the required size of the battery, it will be working with it. And then the other one shows the type of the battery. There's tubular and SMF. That SMF is a seal maintenance free battery, or the dry type of the battery. That dry type doesn't require a maintenance. The refilling of the distilled water is required on the dry. The dry one, you only buy it and come and install it. No maintenance. Then the LA at the bottom of the middle button is lead acid battery. The tubular that I've shown you is a lead acid battery. There is lead acid and lithium, but this one is a lead acid battery. So that is it about the components. Let me show you how the connection is being done in a diagram. There is a system architecture that shows everything about the connection, all the components and the wiring. That is the diagrammatic representation of the system. Let's go there. So this is the system architecture of the UPS solar system installation. As you can see, the diagrammatic representation of the whole thing. This is the battery, positive, negative. This is the inverter or the UPS. It is a 12 volt UPS or the inverter. The battery too is 12 volt. The voltage is very important since you are connecting the UPS directly to the battery. There is an interface between the UPS and the battery, so the voltage must be the same thing. But if you have two batteries, they must be connected in parallel, because in parallel connection you are maintaining the voltage of one battery and you are adding or increasing the ampere hour, that is the capacity of the battery. So for you to maintain the voltage of the battery so that it can work with a 12 volt UPS, you must connect the two batteries in parallel. But when the connection of the batteries are in series, meaning you are adding the voltage and maintaining the capacity of the battery. So example, if you have two battery of 12 volts and you are connecting them in series, meaning you are adding the 12 volts to become 24 volt, but your UPS is in 12 volt, you know that it will not work out. It won't work out. 24 volt from the battery, because it is being connected in series, and 12 volt of the inverter, and doesn't correspond. So that is why I said the two batteries must be connected in parallel for you to maintain the voltage of the single battery and add the capacity or the current of the two batteries. And that is it. Then the AC input here shows the AC current that comes from the external source. You know, UPS system serves as a backup system. There must be an external source or another source of power, maybe from your national grid or any company that sells you or supply you with power. So the UPS works with an external source of power, and that is why this AC input is here, because it is being used to charge the battery via the inverter. So in case of a power cut from the external source, you now use the UPS as a backup to cover up with that downtime of power at that moment. So that is it. It comes from a double pole circuit breaker or main circuit breaker that's been connected with a meter. Then this one at the top is the AC output. The AC output is the one that is going out from the inverter to supply the appliances in the building whenever there is a power cut from the main power supply. So this is how it works from the battery, the inverter, and the external source, and then the AC from the inverter that supplies the appliances. Hey guys, this picture is clearer because the writings appear more clearly. Yes, so you can use it and see everything about the diagram. Look at the writings, and they are clearer. So thank you very much for following. Thank you for watching. Thank you for subscribing, and watch out for more videos.